It's important to know that any given problem type for most of your mathematical topics can be worked in reverse. We saw in the last video that we can find the volume given certain objects, whether it's a radius or a height or depth, things like that. What we will see now is that if you're given a volume and some part of your information, you'll be able to find out other things about the figures. For example, let's say that the volume of a cylinder, so we'll say volume of a cylinder, is 37 cubic inches. And let's say its height is 4 inches. Let's figure out what the radius would be. So we'll say, what is the cylinder's radius? Notice here, this is still a volume problem. We still want to use our volume formula where we know that the cylinder's volume is pi r squared times its height. But we want to find the radius. And you can do this one of two ways. You could plug in all your values first and then manipulate your problem. Or, in general, you could think about it this way. R squared is being multiplied by h and by pi, so I could divide both sides by pi times h. And I'd find out that r squared equals the volume divided by pi times h. And I know that if I have something squared and I want to find its original version, so instead of r squared I want just r, I could take the square root of both sides. And what I've done here, because I haven't worked with any numbers yet, is I've actually generated something that I can use for every cylinder that I run into. For all cylinders, the radius is actually equal to the square root of the volume divided by pi h. Now, I don't tend to memorize this. I usually just use this formula over here and rearrange it as needed. But if you did happen to remember this, or if you were working through an assignment and you found, multiple problems with the same question, you'd be able to just keep reusing this form you came up with. And so we can find out very quickly that our radius in this case is just 37 divided by pi times 4, all under that square root. And that's something that realistically, because pi is so messy to work with and 37 is kind of a nasty number, we could just go in real quickly and just type that into the calculator. I wouldn't expect anything too fancy here. Try to save a few keystrokes on how I plug this in. But we see about 1.72 would be approximately what our radius would be here. So about 1.72, and that would be measured in inches, keeping in mind that we have volume and they gave us inches cubed, or cubic inches. And that's it. I mean, that's all there is to it. You take the formula, rearrange it to find the thing that you want, and then just plug in the values you were given. Now again, you could have done this by plugging in the values first. You could put height in, you could put volume in, and then solve that equation instead then. And it's going to give you the same value. So if you want to try that on your own, feel free to do so. Let's try another one. Let's suppose the volume of a triangular prism, I'll just write it this way, the volume of a triangular prism is 768. And so notice I'm not giving units this time. It's not a big deal. I just want to point that out, that doesn't have to be an issue. Let's say that the figure looks like this. So general shape here, not a perfect drawing by any means. Let's say we're looking for this measure here. Let's say this is what we want. And let's say that this height of this triangle is 16. So we're going to say the height of that triangle is 16. And the height of our prism, we're going to let that be 8. Well, I know that the volume of a prism is big base times height of the prism itself. I know that this big base is supposed to be 1/2 little b times 16, and that the height of the prism is 8. So this is what I have right now. So this is what I meant by, well, we could just go ahead and plug in the numbers we know first. The only thing that I haven't done is plug in the 768. So let's just say, well, that's equal to 768. We'll say that here, and so we can kind of just ignore this little v. Let's multiply this out then. 1/2 of 16 is 8, and then 8 times this 8 would be 64. So this would be 64b equals 768. And if I were to divide both sides of this equation by 64, we would find out that b equals a number. Let's see what that number ends up being. We're going to hope this one works out kind of nicely for us. Let's see if it does. It does. Look at that. All right. So that means that that base of the triangle will actually have a length of 12. Now here I don't need units again, so I don't have to worry about that. They did not give me any units, so if they went in and added in after the fact, if they said this was cubic feet, then this would just be 12 feet. But they didn't tell us, so we'll just move on with our life. Just to get one more example, and I always feel like at least 3 examples for things of this nature is a good way to go. Let's do the volume of a sphere. Let's say the volume of the sphere is 457, I don't know, let's just pick a unit to work with. Let's go with meters cubed. We don't use meters very much. I want to find the radius. I like seeing a problem like this just because for a sphere, you just need to know the volume. The sphere was interesting in the fact that its formula, which again was 4/3 pi r cubed, this formula only has one true variable, that's the r. The r results in whatever your v equals, of course. So you could say that v is also a variable, and that's true. But in general, when we plug in our volume, though, when we plug in our 457, we see that 4/3 pi r cubed. This one's also unique a little bit in the fact that it's the only one of our formulas that we work with where we'll need to use a cubic root to get out of there, to get the r out of there. All the other ones, r ends up being squared, so you just take a square root. Now, I tend to be of the mindset that fractions should be taken care of in a problem first, so I like to multiply both sides by my denominator, by 3. So real fast, we'll just do this in the calculator. Since it's a 3-digit number, we'll just make our lives a little bit easier. And I almost divided. Look at that. That's awkward. We're going to multiply both sides by 3. We get 1371 is equal to 4 pi r cubed. And then from there, it's easy enough to do some setup like we did in the previous problem. So I'm going to divide by the two things I'm multiplying by. I want this to be divided by 4 pi. And that's going to give me r cubed. And we said to get r by itself, we should take a cube root of both sides. So we're just going to take a cube root of 1,371 all over 4 pi. And we're going to see that this right here, very nice and neatly, can be plugged into a calculator. It may not be the prettiest number in the world, and that is okay. So let's go ahead and find it. Now on my calculator, I go down to the math menu, and there's a cube root option here. Depending on what you're working in, you may need to do something else to get there. So we have 1,371 on top, we have 4 pi on the bottom, and then we just pop out of here and go, okay, we get about 4 let's see, the 2 decimal places is typical, so this 7 gets bumped up to an 8 because there's an 8 behind it. So we're going to say r is approximately 4.78, and we were working with meters cubed in our volume, so our radius is just in meters. And there you have it. There's a few examples of how to work backwards when given the volume of a solid object.